Now this time we're going to go in the opposite direction. They're going to give us a list of terms in a sequence, and we are going to figure out what the nth term looks like. In other words, we're going to find the formula for the nth term of the infinite sequences that are listed here. There's 2 of them. And they tell us do not use a recursion formula. Now you recall a recursion formula is a formula for the nth term, a sub n, that depends upon terms that came earlier. So on this one, we cannot have it depend on an earlier term. It can only depend on the index n. Let's look at part A. Here's the list. Here's the sequence. The first term, a sub 1, is 1/2. The second term is 1/4. The third term is 1/8. The fourth term is 1/16, etc. Now, to do part A, let's just go ahead and start part A. To do that, we just, let's list the indices so we'll know the positions. This is going to be the first term, the second term, the third term. See, I'm listing the index n. And below, we're going to list the first term, a sub 1. It's 1/2. Now, if I write it with the first power, it's still 1/2. I've been thinking about this. If I write it as the first power on the 2, it's still 1/2. And that's exactly what the first term is. And I'm going to put a box around that 2, that 1, because that 1, the power on 2, it agrees with the index. Now look at the next term. It's 1/4. But I could write that as 1/2 to the second power. And now the exponent on the denominator, it agrees with the index too. Now the next term, a sub 3, is the number 1/8. I can write the 8 in the denominator as 2 to the third power, and you notice I put a little box around it, emphasizing that the third power on the 2 in the denominator agrees with the index. So what do you think the fourth term is going to be? Well, if we follow the pattern, it should be 1/2 to the fourth power, which is 1/16. And look at the question. It is indeed, the fourth term is indeed 1/16. So we have stumbled upon a formula for the nth term. All we have to do is say that the a sub n, the nth term, is equal to 1/2 raised to the power of the index. So the nth term is 1/2 to the n. See? It takes some thinking, and the answers are not unique. There's probably other ways to come up with an answer, but this one seems like the most direct answer. Doesn't matter. You just do the one that works. Make sure it works for every term. Okay, let's look at the second list, part B. The terms in that list, the first term is 1/7, the second is 1/9, then 1/11, 1/13, 1/15. Okay, now we're going to list these terms under the indices n equals 1, n equals 2, n equals 3, so we can look for a pattern. Now, 1/7, how does that relate to the index 1? Well, you know, I can't really see it yet. How about 1/9? How does that relate to the, well, it's, you know, 7 is like 5 plus 2, and 9 is 5 plus 4, but we skipped from adding 2 to adding 4. 1/11. 11 is 5 plus 6, so we skipped from adding 2 to adding 4 to adding 6. Well, you know, those are even numbers, so we can get those numbers by multiplying the index by 2. Check this out. The first term, 1/7, is 1/2 times 1 plus 5. And you see that? That is 1/7. Now, for index n equal 2, let's write 1/2. Okay, that's the first term, 1/7. We want the second term to be 1/9. 1/2 times 2 plus 5. So we replace the 1 that was in the parenthesis in the first term with the 2 in the second term. It matches the index. And the next one is 2 times 3 plus 5. That gives us a denominator of 11, which is exactly what we want. And the 3 in the parentheses matches the index. And the next one's 1/2 times 4 plus 5, then 1/2 times 5 plus 5. Each one of these gives us the correct term in the proper place. So we can see a pattern developing here. The relationship between each of these terms and the index n is that it's 2 times, in the denominator, it's 2 times n, the index, plus 5. That means that our nth term, b sub n, is equal to 1/2 times the index n plus 5.